Hi guys, how's it going? Good? Perfect. So, my name is Solomon. I'll be talking to you guys about scaling with PWA, which is Progressive Web Apps. Has any one of us worked with Progressive Web Apps before? One each? Okay, cool, nice. We'll see what we can do today. Cool. So who am I? My name is Solomon Ayoola. I'm from Lagos, Nigeria. Well, I'm a front-end developer based in Berlin. I've been here for close to 3 years, but I don't speak German, which is really bad. Currently working on Smava. Smava is a loan comparison company. So we are like number 2 behind Check24. So I'm also part of the Adeva developer community. So what Adeva developer community is a collection of really good, talented developers that we work remotely. So if you want to talk to me about it, we could talk afterwards. And let's just get started. I need to, 1 minute. This full screen. Cool. So before we get started, let's check out some data. So sometimes in 2016, there was a report from Comscore in the US from age 18 upward. It says the number of unique visitors on the web is 11.4 million compared to 4.0 million unique visitors on Android or iOS application or devices. Now, let's move down to the next one, which is average minutes per visitor. A user will spend up to over 188.6 minutes on a mobile phone or on a mobile application than checking out on the website, which is really poor. So if you look at the monthly unique visitors compared to the average per minute, it's like something is going on really not really good. And what was the issue? Let's check out some stats. Do you know that 53% of users will abandon a site if it takes longer than 3 seconds to load? So if your app or website is taking forever to load, I'll just close the browser and go away. So that's one of the reasons. Secondly, about 60% of the world population is still using 2G internet. Even in the US, some people are still using dial-up to access internet, which is super slow. And that will also make your, I don't know, for example, you're in Germany and the server is in US. Just look at it. And also, you can get over 27% increment in conversion rate if you improve your page loading time. It's super simple. When you increase the performance of your page, you get high conversion rate. So even if it's 1 second, 1 second is a very huge stuff to work with JavaScript, fatigue all over the place now. We can also get 2% more revenue for sites that load in 5 seconds compared to 19 seconds. And lastly, speed plays a major role in user retention, especially on mobile devices. We can re-emphasize this over and over and over again. What happens if you open a mobile application? Instantaneously it loads. You don't have to worry about fetching something from the internet because most of the data it needs is already on the mobile application, so it doesn't have to go outside to fetch some data. So it's really important for us to emphasize speed. Speed also plays a major role in the way our ads are being popped up on Google on searches or search engines. For example, if your site is like 19 seconds, takes 19 seconds to load, probably your ad is not going to be coming up on the first pages of Google searches or Bing or however. So speed, it's a very vital piece of what we work with in the web. So what are the challenges we're facing currently on the web? One, pages and sites take too long to load. We already know that. Secondly, limited access to device capabilities. On the web, we don't have access to offline. We don't have access to push notification. I'm on my phone, but there's one thing that makes us to always use WhatsApp, because it's engaging. We always want to go back. If someone sends us a message, we always want to go back and reply the message. So because there's push notification, we are always going back and forth between WhatsApp and some other of our apps. Then also add to home screen. There's not an avenue for us to basically have like a mobile or a web application where we could basically say, okay, after this page is already loaded on my phone, I want to add it to my screen so that I can be able to access it quickly. That's one of the challenges we're having. And the last is, even completing simple actions with forms could take forever. This is some, I don't know, random behavior with some forms. So it's some of these challenges that's making it difficult for us to get the number of, for us to get even close to the data I showed earlier on. So what's the solution? Let's think about it for a minute. What do you think the solution is? Anybody? Really? Are you sure? Anybody else?
Only one feature per page.
Only what?
Only one feature per page.
That's difficult. Well, you get it right. Progressive web apps, which is why we are here today. And so what are progressive web apps? Anybody has any idea? Not you, please. Maybe somebody else.
It's websites that's enhanced with certain features like offline storage, and as you already said, push notifications and online-offline indicator and so on. That feels like a native mobile app, but is just a web page.
Cool. Any other definition or thoughts? Okay, cool. That's nice. Well, simple. Progressive web apps are web applications, simple, that are loaded like regular web pages or websites, but can offer functionalities such as working offline, which is already stated. Push notifications. Maybe you saw my slides before, I don't know, but it's really spot on. Push notification and device hardware access, traditionally available only to native applications. So we've said it enough. Progressive web apps are just like web application, but with an add-on. It's progressive. Even if we don't have, even if our browsers doesn't support some of these functionalities or features, our pages will work as it's supposed to be. But if the browser we're using supports some of these things, then we could go a step higher. So why build a progressive web app? Improve conversions. The ability to deliver an amazing user experience. AliExpress, everybody knows AliExpress, to get over 104% by across all browsers, and also iOS by 82%. So they were able to improve the conversion by moving towards progressive web applications. Secondly, increased engagement. With the help of push notifications, we will be able to really engage users, even if they are not on our pages, because we have all the functionalities available to do that. Work reliably, even without no internet connection. So with the help of service worker, we're talking about momentarily, we will be able to have like an offline, how do I say this, offline functionality into our application. And lastly, worthy of being on the home screen. So if there are some criteria before an application or web apps could be allowed to be installed on our mobile phone. If those conditions are not met, there's what is called an app banner that pops up after like some interaction with the user. So if those checklists are not met, then the banner will not be popped up, so user will not be able to install them on their mobile phones. So let's check on some case studies. Flipkart leveraged offline access and add to home screen with traffic roughly over 200 million users. They were able to increase the number of times a user spent on the website. They were able to get an increase, 40% higher re-engagement rate, 70% greater conversion rate arriving from the home screen. Because of the re-engagement, we were able to install on the mobile phone. Then you quickly click on the app notification or app image or icon. Then you were able to convert faster. Then they were able to lower the number of data that was used. Secondly, AliExpress. Again, AliExpress we're investing in fast and smooth user experience. It really pays off. They got over 104 more new users across all browsers, 82% increase in iOS conversion rate, 2% more pages visited per session per user across all browsers, 74% increase in time spent per session across all browsers. And lastly, Conga. This is from my country. So they built the application from ground up using progressive web apps, and they were able to get cut data usage to 92%. 92% less data for initial load versus native apps. 82% less data to complete first transaction versus native apps. 63% less data for initial load versus previous mobile web experience. And 84% less data to complete first transaction versus previous mobile web experience. So because these companies have been able to leverage the power of progressive web applications, they were able to increase drastically their conversion, their retention rate, and also revenue. These are some of the companies that have also been part of the progressive web apps. Removing Hebelin, we've got AliExpress, Conga, Flipkart, Jumia, Booking.com, 5 Miles, the Washington Post, and name it. So enough of the numbers. Let's get to real talk. So what's the technicality behind PWA, progressive web apps? 1, the web app manifest. 2, service forecast. 3, the application shell. We'll talk about that soon. Then we're going down, intercepting network requests. And a little using Workbox. Anybody worked with Workbox before? No? Cool. See? Then push notifications. So let's get started with web app manifest. So from the little icon right there, it says JSON. And the definition of web app manifest is it's a JSON file that describes all the metadata about the application. It's simple as that. It's also possible to run the web app in full screen mode as a standalone application to assign an icon that will get displayed when the application is installed on the device, and to assign a theme and background color to the app. So we will basically see how the manifest looks like and what are the values, because it's a JSON file, so what are the values and key pair we have to give to them. It's normally called manifest.json. So if you want to use it, we basically say, we'll put it into the header of our website, of our HTML, just like that. Now it looks like this. We've got a name, which is code.talks. We've got short name, description, icon, the source for the icon, the sizes, the type, the start URL, display, orientation, theme color, and background color. So let's start with the name. It's very simple. It's a very human-readable application name. It says commerce, code talks. It's super simple. Everybody knows what the name is. And short name. This is the name that's going to be one after your user installed it on the mobile phone. This is the name that's going to be shown to the user instead of the long one, because you can have like the maximum number of characters we could have there is 12. If it's more than that, it gets truncated. So we want to have a simple code name, short name for our application. Then descriptions. What does the app do? For example, you have an application that is, I don't know, to check, to buy something online, probably Zalando, about you, commerce tools and stuff. So you have to describe the application. Now the icons is quite straightforward. So we want to, because as a web developer, a front-end developer, we work with several browsers. And some of those browsers behaves differently. And to be able to work across board, we have to cater for all of those browsers by providing icons for Android, iOS, Safari, Firefox, even Internet Explorer at some point. So we have to be really careful. And the sizes for which icon, depending on the screen of the ratio, or aspect ratio of your mobile phone. We want to give you a very nice icon to install onto your application. Then we have the type, JPEG, PNG. And the start URL is like the entry point of your application. So if you install an application onto your mobile phone, when you click on the icon, where does it go to? First page should be your index.html. So it's always starting with the slash. The display here, we want it to be standalone, we want it to be portrait, or we want it to be, standalone. Say we don't want to see the browser headers and stuff. We want the user to see the immersive experience of using a native application. So it's going to be standalone. When a user clicks on the icon, it basically says it's still a web browser, but the headers have been removed. So the user doesn't have to click on the URL, change the URL. The orientation, we could have a portrait or landscape mode. So if you're building a web application, which is a game, we want to make it landscape, because portrait is very small for you to do whatever you want to do. And the theme color is super simple. What theme are we using for our mobile application? And also background color. How do we want to do it? It's straightforward and in human readable form. So as I said earlier, there are some criteria to be met before an app could prompt that banner. It's very, very important. 1, must have a valid web app manifest, which we just described. 2, it must be served over HTTPS. The reason for HTTPS is that because we will be intercepting network requests, we don't want somebody, like a man-in-the-middle attack, man-in-the-middle, to be able to interfere with all of the resources we're making calls to back and forth. So it needs to be really secured. If it's not secured, then web app service worker is not going to be available. And all of this is not going to be done. Then third one must have a valid service worker. And the last one is must have been visited twice with at least 5 minutes between each visit. So the user needs to have interacted with the application before that prompt will come up. You can't just you can't just start going to the website and just close it. It needs to be interactive. If it's not interactive, if user is not interacting with the application, then the prompt is not going to be coming up. Then after that, then we have the icon. When we click on that, it shows the application. It depends on what you want to do. Is it standalone on the right? Now let's talk about service worker. What is a service worker? Anybody? Not you, please. No. You can help us out. Yeah, you. No, you. Yeah, yeah.
Basically, it's a proxy between the browser and the device.
Okay, so before service worker, what we're using to trying to do to get like an offline experience on our applications? Anybody? Have we heard about app catcher before? Okay. A service worker is a script that the browser runs in the background, separate from a web page, opening the door to features that don't need a web page or user interaction. It's straightforward. It's a script. It's a JavaScript script. Anybody know what's a web worker here? Okay, let's say it's a JavaScript web worker. And web workers are meant to be running on the background. An example of a web worker is use is, for example, if you, as an e-commerce company, you got some groceries, for example, you want to scan them so you want to like add them on the product, for example, and by scanning the QR code, it could take a while, and we don't want to block the screen while we are scanning that into the system. We could take that big, huge calculation and move it to the web worker to do that for us. So, and it's going to be running on the background, so it doesn't interfere with the main thread. So this is basically how service worker works. So these are the do's and don'ts of a service worker. One, we don't have access to the DOM element. We can say, in a service worker, I want you to do window document.get element by ID, blah. It's not possible. Two, it needs to be secured. Three, can terminate when it isn't in use and run again when needed. So it is event-driven. So if a service worker is already installed on your browser or an application, if you're not if there is no interaction, then it's just going to be idle until an event is being triggered. We can control how network requests are being handled, which is very important, so that we could get the offline functionality working. We could also do some background sync and push messaging. I just explained how we could use a web worker to do some heavy lifting calculation out of the main thread. It uses promise extensively. So if we don't have experience working with promise, it's going to be difficult for us to work with service worker because most of the APIs we're going to be interacting with are really promise heavily based. So now let's talk about the service worker lifecycle. We have the registration, which is like the no service worker stage. Then we go to the installation. If during installation something goes wrong, then nothing has been, then the service worker terminates. Then if everything goes well, like fine, we go to the activated stage. Then if there is no event being called, it becomes idle until a fetch message or a push message is being, event has been called, then that's when it becomes active again. So let's look how a registration is being handled. So first, because of some of our browsers do not support Service Worker yet, Safari and Internet Explorer. So we need to check if Service Worker is available. If it's not available, which is why it's really important, it's progressive. If by tomorrow Safari is okay, we're fully supporting progressive web apps, and you have all of these available, then it just works as expected. If not, it just gets out of the... So we check first if Service Worker is available in the navigator. Then we register the Service Worker, which is normally, regardless of the name you give to it. Then it comes back with a promise, with a registration. Then we could basically log the scope. Now, it's very important yet to note, if when we're registering the Service Worker, let's say you have some directories in your application where it says about, and we register the Service Worker on the about, it needs to be really, then the Service Worker is going to be running on that about, and anything below about, that's where it's going to be running. So anything above it doesn't work. So the scope is very vital here. Now the installation, that's the next event. We just save the add event listener, install, then we could do some stuff during installation. Then the activation stage. So as I've said, it's event-driven. It's super simple. Save.add event listener, activate, then we could do something with the event. Now these are the support for Service Worker on all major browsers. Firefox is trying, Chrome, Safari, and some other stuff. But Internet Explorer, super red. Now the second one is application shell. The application shell is the minimum HTML, CSS, and JavaScript required to power a user interface. A native mobile application includes the application shell as part of distributable, whereas websites originally request this over the network. Progressive web apps bridge this gap by placing the application shell's resources and assets in the browser's cache. So this is how an application shell looks like. So we create a resource into the browser. First, we respond with this minimal HTML and JavaScript that's required for the page load. Minimal, very minimal. As small as possible, so that user could see something. We could have like a loader in the middle here. So the first two screens are the application shell, and the last one there, those are the dynamic data. So those two guys are like static data, where we don't have to make a call to the API, make a call to an API to get data onto the browser. So as quickly as the user make a call to our website, it gets the application shell. Then this could be cached. Then the subsequent visit is going to be instantaneous. We don't have to go back and forth to the network. So this is how it looks like. We have a catcher name. So if you want to catch an application shell, have a cache name. So we say event.add self event listener.install. Then we say event.wait until. Event.wait until takes a promise. Until that promise is being resolved, it's going to be waiting until it's resolved. If it fails, then the service worker installation process is going to be terminated. So here we're going to be, so let's say this is our minimal application shell. We've got our styles, the script, the vendor, our fonts, and offline. So it's like a minimal CSS and JavaScript we need for our page to load instantaneously. So during the installation event on the service worker, this is being cached. So then on subsequent visit, it's going to be super fast to put it up. Now, how do we intercept network requests? By listening on the fetch event. We could listen to network requests and also our images on our page that we're not making a call to on the API. Images, CSS, HTML, and JavaScript. It's as simple as saying self.add event listener and listening on the fetch request. Then we got, so these are the event.request, which is the request object. Event.request.url is URL that we're requesting, and the method, the HTTP method. Then we could always respond with something other than what was requested. For example, we could say, okay, say if we're making a request to an image that goes to, of a dog, we could say, okay, we're not responding with the dog, we want to respond with a cat. So which is why HTTPS is very vital. So somebody can't just mess up with our resource. This is the simple way to intercept a network request. We have listening on the fetch event listener. We're responding to, first, let's say we have already something in the cache. We have to event.request on the cache. We're matching it. If it's available, then respond. If it's not, then go to the normal way of fetching requests. So we're saying, okay, I want it to be offline first. If it's available in the cache, send it back. If not, use the network. So there are several caching strategies that are involved that the user could use, or that we could use to make our application really offline. Different scenarios could be, for example, if it's a blog post or a game leaderboard, we want to always show the current version of the response of whatever we're doing. So in that case, the offline first method is not going to be working. We want to do something else. So there are other caching strategies we could have used. We've got cache first, network first. We've got cache, then network. This is it, yeah? Then we've got network, then cache. Then we saw cache and network. That's like a race condition. First, we have to go into the cache. If there's something returning, so then if the network comes back, we update optimistically. Now, a simple using Workbox. So it's going to be, sometimes it's going to be super difficult or repetitive for us to start writing service worker every now and then. Workbox is a collection of libraries and tools used for generating a service worker. Pre-caching, routing, and runtime caching. It's a tool made by Google. Workbox also includes modules for easy integrating of background sync and Google Analytics into our service worker. We could basically track all our events using Workbox, even when we're offline. How cool is that? How do we use the Workbox? First, we use import script to import Workbox library. Then we'll define our pre-caching. Let's say this is going to be where our application shell will be. Then we'll say, OK, now I want you to do some things for me. If we request for image, I want it to be cache first. Cache first means I want you to check into the cache. If it's available, respond. If not, use the network. So that I just explained to you. Then we've got a name. We've got expiration plugin. We wanted the number of entries of the image we're storing in our cache should be 10, and we want to say give it 7 days maximum. After 7 days, Workbox does all of the smart enough to remove the image in the cache, whereas we will have been handling that ourselves. It's going to be like super trivial. This is if we want to use Workbox with our configuration. Like, for example, we could use it with GUP. We could use it with Webpack. We don't have to specify some values into the array. So if we bundle it with our Webpack, what we're saying is, we say, Workbox, go into the source, serviceworker.js, put it into the destination of build. Go into, this is where our build folder is. There's, I want you to cache all of these for me. This is going to be our application shell. So we say, OK, go into the global patterns, find all of these, and put it in to the pre-cache. So this is how it looks like after bundling with Workbox. We don't have to manually do all of this ourselves. Every time we make a change to our build process, or every time we make a change to our JavaScript, or CSS, or images, this is going to be populated. So the good thing is the revision. So if at one point in time we got a new index.html, so Workbox is smart enough to go into our cache and check if the value that's coming is the same as what was before, then it updates. If not, it just moves on. So last thing is the push notification. Let's go through this for a simple seconds. It's like I want something, I want to buy something. I want this to be engaging. So what if I miss out? He doesn't want to miss out, of course. Now, push notification is a message that pops up on the user device. Notification can be triggered locally by an open application or can be pushed from the server to the user, even when the app is not running. They allow users to opt in to timely updates and allow users to effectively re-engage users with customized content. So push notification is like 2-in-1. We've got push API and the notification API. The push notifications are built on top of Service Worker API, which respond to push message event in the background and release them to the application. Workflow of a typical push notification. We check if push notifications are supported on the user browser. We register the service worker, request permission to send notification, generate a pops-up object and send to application to store in the database, and we make money by re-engaging the user. Here, we check. So in addition, that's why we said push notification is built on top of service worker. So we have to check for both in the browser. If not, we're not going to be doing anything. The way we register the service worker, as we've seen before, and request permission from the user. So here, the default notification permission is default, says. So then we request it by requesting notification.request permission, then the response is going to be it's either granted or denied. If a user denied the notification permission, then we will not be able to send push notification to the user. If it accepts, then fine. It looks like this. If I say block, then it's going to be denied. If not, allow, then I'll be granted. Then the last part is generating a pops-up subscription object. So we register it. After registration, and we've gotten access, permission from the user, we want to get the subscription. After getting the subscription, we want to subscribe to it. After subscribing, then we want to send the data to the database to save it. So anytime we want to send a notification to the user, we just initiate it from the data or from the server, and it basically just goes to the browser and show the notification. It looks just like this. So if on a Facebook notification, if click this, it's going to open the application, which is really engaging for us. And the support for push API on all major browsers is not good. So currently, Chrome and Firefox are really doing well. Hi, no. iOS Safari, it's not convincing, but it's a way we could be able to drive forward engaging users. So in conclusion, progressive web apps are reliable. They're fast and engaging. They load instantly. They respond quickly to user interactions. And it's very engaging with the help of push notification. Thank you. Questions? We're not going to leave here till anybody asks, until somebody asks a question. Okay.
I read once iOS devices don't have such a good PWA support.
Yeah.
If you got some experience on it, could you tell about it?
Yeah, cool. We know iOS devices are very, sometimes it's not reliable. So one way to be able to tackle that is one way they support service worker, but not all of them. Because progressive web is progressive, so we have the if condition, then we go inside of it. So what we can do in that case, if we want to make it immersive, we'll, the iOS browser have like a menu that we can click on that shows off some options. Then we can add, there's a link that says add to home screen. That brings it up. When you add to home screen, then we could give it a name we want. Then we can add that into our iOS application. That is one way to not programmatically add our application onto our iOS device. That's like a way to be able to add that into, to be able to have the immersive experience. Although iOS does not fully support PWA as of today, but there have been works, there's currently ongoing work to be able to improve the usage of PWA. So one way to do that is if you want to have to home screen, we have the simple menu we click on. It pops up some options. Then we could have, basically there's like an add to home. We click on the add to home, then we're manually doing that instead of programmatically doing all of those stuff. But the good thing is we have the web app manifest. Even it's supported across all browsers. So we've got all of our icons that will be able to do some things for us. So one way to generate a web app manifest, if you don't have to do it by hand, there are tools that could help us create the web app manifest, and we could basically copy some of those configuration of the meta. I'll put it into our index.html. That will give us some of the immersive experience on those iOS devices compared to Android, which is like by default. Does that answer your question?
Yes, thank you.
One more? Okay, we'll call it a day then. Thank you very much.